Assalamu alaikum wa rahmatullah. Hi everyone. In this video we will be doing another question from the file of question 2 of the coverage of a grade 11 elite. So we have two buildings as shown. They are 50 feet apart. So this is 50 feet apart. There is a tight rope goes from point A to point B, and there is a tightrope walker walking at a constant rate of 2 feet per second, right? So if we are going to call this little distance x, right? So there is dx over dt, which is equal to 2, right? Because x is increasing, the tightrope walker is moving from point A to point B, so x is increasing. So because it's increasing, there is dx over dt. Okay, and as the tightrope walker is moving, there is a shadow, right, on the ground, down, moving along the ground from building, the first building to the second one, from A to B. Okay, how fast is the shadow of the tightrope walker's feet moving along the ground? So we need to find what? We need to find, 1 second, yeah, if we call this one here y, we need to find dy over dt. This is what we need to find in part A. So let's find a relation that relates x and y. Well, I can see here similar triangles. If I highlight the first triangle in yellow, this is the first triangle, and if I highlight the other one, for example, in red, that would be the second one here. So those two triangles are similar. So if we graph them here, so we have this distance to be 70, this distance to be 30, and this is y and this is x. So we can find now a proportion out of these two triangles. So we can say that y over 100, because this side here is 100, y over 100 equals, if you follow the same order, it will be x over 70, right? And we are looking for dy over dt. We can multiply, before we differentiate, we can multiply by 100 here and 100 here. So y equals 100 over 70, which is 10 over 7, right? So this is 10 over 7 times x. Differentiate, you get dy over dt equals 10 over 7 dx over dt. So this is 10 over 7, and dx over dt is given, which is 2, so 20 over 7 feet per second. This is part A, 20 over 7 feet per second. Part B says how far from point A is the tightrope walker when the shadow of her feet reaches the base of the G building. So that means we need to find the value of x when the shadow reaches the other building, yani when y equals 50. So we will use the same proportion we have used up, right? Or we can, we can use the same proportion. So for part B, the proportion we used y over 100 equals x over 70. This is what we used in part A. So just substitute y equals 50. 50 over 100 equals x over 70. That means x equals 35 feet. So the question says, how far is the walker from building or from the point A? It will be 35 feet. This is when the shadow reaches the other building. Okay, so part C says, how fast is the shadow of the tightrope walker's feet moving up the wall of the T building when she is 10 feet from point B? Okay, so now let me sketch the graph I'm going to use. Okay, so there is 70 from this point to this point. There is 30, right? There is y, okay, which is going to be 50 here, right? Here we have we named it x, right? We named it x. Now so what happens here is that the building, the second building is here, right? The second building is here. Now the shadow will start rising on the second building, on the T building, right? So how fast is the shadow moving up the wall of the second building? That means we are looking for the rate of change of this segment here. So if we name it B, that means we are looking for dB over dt. We are looking for dB over dt. Now let's name this one A, okay? And we need to find this dB over dt when A is equal to 10, because the walker will be here, okay? The walker will be here, and we need to find that when A is equal to 10, when the walker is 10 feet from point B. So we can set up a proportion now. If you look at those two triangles, let me name this one triangle 1 and name this one triangle 2. Let's set up a proportion. Now we know that B over A is the same as 70 over what? 70 over x. 70 over x. Now we are looking for dB over dt. We know dx over dt, right? It's given, but we don't know dA over dt. So we must eliminate dA over we must eliminate A. How do we do so? We know that here, this distance here, it's 50. So 50 equals x plus A. You move the x to the other side, 50 minus x will equal to A. So this is B over, instead of A, we can write 50 minus x equals 70 over x, right? Now, what can we do? We can do cross multiplication. B times x is bx equals 70 times 50 is 3,500 minus 70x. We're looking for dB over dt. We can differentiate, okay? Notice that here you must use the product rule, because both are function of time. So the first one is differentiate the first, we get dB over dt, leave the second, plus leave the first, differentiate the second, right? equals 3,500. The derivative is 0, so we don't write it. We've got minus 70 dx over dt. So let's put the given on this equation and let us see what are or what is the thing we are looking for. The thing we are looking for is dB over dt, right? So just a second. So dB over dt is something we are looking for, right? Okay, times x. Now x is equal to what? When a, let me write it here. When a is equal to 10, x will be 50 minus 10, which is 40. So times 40, right? Plus, we don't know what b is, right? But we know that dx over dt is equal to 2, equals minus 70 times dx over dt, it's given, it's equal to 2. Now everything is there except b. So how do we find b from the graph? How do I find b from the graph? So you've got to go back and find the value of b by using what? By using the same proportion we used at the beginning. B over a equals 70 over x. So we are looking for b. We know what a is. A is equal to 10, right? Equals 70 over x, and x will be 40. So use cross multiplication. Multiply 10 times 70 and then divide by 40. You must get b equals 17.5. After finding b equals 17.5, just put it here and then you can solve now. So this is 40 dB over dt plus 2 times 17.5 is 35 equals minus 140. So solve this one for dB over dt. You get dB over dt equals what? 35 over 8 feet per second minus 35 over 8 feet per second. 35 over 8 feet per second. So this is how part C is done. Good luck.